All right, here we go. Let's talk about 12.3. So, first things first, just a couple of things. One, you're going to need your TI-84 calculator to help you out with this. You do not want to do standard deviation by hand. It is long, it is very, very tedious. There's a lot to keep track of, and it's easy to mess up doing it by hand. I will show you how to do standard deviation by hand one time and only one time. Okay, because it is a very, very long process. All right. Now, so make sure that you're using that TI-84 calculator. I encourage you, I need you, I want you to use that TI-84 calculator during this section. And you're going to use a lot of the same functions that we talked about in 12.2. Okay, so using that stat list and using one variable statistics, all that stuff. Okay. Now, second thing, what you're looking at right here, I surveyed all of my college mathematics courses, and these are the data surveys that I got yesterday from it. So I've got 24 student pieces of information, 24 student data entries, and then this last one right here, that 24, that one's me. So what you're looking at here are the number of games that students have on their phones in my college mathematics courses. And again, I am taking this from you because I know this first data entry is from Jason. I don't know who the second entry was because it was a different email, didn't allude me to any names. The third entry is from Stephanie, and then the fourth one is Nidelke's. And again, like I said, the last one, that one's coming from me. So this is actual data that you guys have provided us, and there are 25 numbers total, which is important to us. Okay. So we're going to run standard deviation on this here in just a couple minutes. But before we do that, let's talk about what is standard deviation. Well, standard deviation, its formula looks just like this. This little Greek symbol right there is what we call sigma, okay? And it's the square root of epsilon, and that's a capital epsilon, parenthesis, your data entry minus the mean, because remember x bar means mean, parenthesis squared, all over n minus 1. Okay? So you can see that that formula is very, very involved. Now, just so you know, there are other formulas that get longer and much more involved than this. You'll see them soon enough. But what does standard deviation mean for us? It what standard deviation is that it's a measure of how far away the typical observation is from the mean. Okay? So it's really about the spread of our data. Okay, the closer your data is to each other, the smaller the standard deviation. The larger your data is spread out, the larger the deviation. Okay, smaller standard deviations means your data is really close. Large standard deviations means your data is really spread far out. Okay, so that's kind of the idea of standard deviation. It's really just about how far stuff is away from the mean. So let me show you standard deviation by hand, and then we'll talk through the calculator. So the first thing before you can do any standard deviation is you have to find the mean. Okay, so we got to find x bar, which means that all we're going to do is we're going to add up these numbers. 23 plus 24 plus 25 plus 26 plus 27. And then we're going to divide that by 5 because there are 5 entries total. Okay? So get out of there. 23 plus 24 plus 25 plus 26 plus 27. So there's our top number, 125. And we're going to divide that by 5. And if you take 125 divided by 5, you get 25. Okay? So we've got our mean. So now the first thing that we're going to do is we need to take the data, each entry minus the mean. Okay? So we're going to take 23 minus 25. We're going to take 24 minus 25. We're going to take 25 minus 25. And we're going to take 26 minus 25. And 27 minus 25. And what we get are the following values. You get a -2, you get a -1, you get 0, you get +1, you get a +2. Here's what's really cool. If you actually go through and add up all these numbers in here, it totals up to 0. Okay? So that's why we have to square these numbers now. Okay? These data values minus the mean have to be squared because we can't run our formula with a 0 in the numerator. So we're going to square all those numbers. Okay? That's where the squaring comes from. Because if we just worked with this information and took the data minus the mean and then divide that by the standard deviation, or not divide by the standard deviation, but divide by n minus 1, it doesn't work because you got 0 in the numerator, hence the squaring. And when you square this information, this is actually called variance. When you get into statistics, if you take 2023, which I'm teaching in the summer, you'll learn about variance. All right? So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. See, now if I add all this up, it's no longer 1. And that's what the sigma is wanting you to do. That not sigma, this epsilon wants you to add all those entries up. So 4 plus 1 is 5, plus 0 is 0, plus 1 is 6, plus 4 is 10. Okay? And then now you're going to take, and we're going to take the epsilon number that we just found, and we're going to divide it by n minus 1. That's the same n that we've been talking about since 12.2. It is the total number of data entries. And so we're going to take 5 minus 1, which is 4. So we're going to have 10 divided by 4. Okay? So 10 divided by 4 gives us 2.5. And the last step that we have to do is we need to square root it. And the reason we're square rooting it is because we're getting rid of the square caused by the variance. So last step, to tell us what sigma is, we square root that epsilon piece. So we're going to take the square root of 2.5 and the square root of 2.5, square root 2.5. Oops, a lot of extra information there. There we go, 2.5. And there's our standard deviation. I think it'll probably want you to round to the nearest hundredth. So we'll just say it is 1.58. So typically, our observations are 1.58 standard deviations away from the mean. Again, you can see why I'm only doing this once. I only had 5 data entries to worry about. That's not too bad. Okay. That was pretty easy to run. But if we go back here, I have 25 data entries to worry about. That's a lot of work by hand. So please don't do this by hand. Okay. So let's talk about how the calculator is going to help us out and where you can find this answer right away. All right. So remember stat and how you can go into edit and put in your numbers. Okay. So you hit stat, you hit enter. Right here, I have already put in those 25 data entries. And again, I know it's 25 because remember, as we talked about, as I scroll down, see how this says L125? That was my data entry, which was the last one. So I know I have all 25 in there. Okay. So once you have that in your list one, you're ready to go. All we have to do is go back into stat and we want it to calculate. And we want to calculate one variable statistics, just like what we did in 12.2. So you hit enter, and again, just hit enter all the way down, or you can just scroll down to calculate. It's all the same. And this is the screen that you've seen before. Hey, look, right here, sigma. Okay? But actually, what we want is we want the sample standard deviation. So let me talk to you about the difference between these two. Okay, because both of these are standard deviation. This one right here is the standard deviation we're after. Okay, so we would say our class data, the typical data entry is about 5.29 standard deviations away from the mean. This is the one we want with the capital S. The one with this one right here, this sigma right there, this is what we would call a population standard deviation. So this is a sample standard deviation, like S for sample. This one right here is what we would call a population standard deviation. What a population standard deviation is, instead of dividing by n minus 1, you would divide by n. Okay? That's the only difference between a sample, which is what this formula is for, and a population standard deviation, which divides by n. Again, when you take stat 2023, we talk more about the difference between those and dive into, standard deviation a lot more than what we're doing right here. Again, we're just running surface value. Hey, can you find the standard deviation? That's it. Okay. We just want you to be able to plug in some numbers, kick out an answer. Okay. So this is what we call a sample standard deviation. And when you're looking at your calculator, we want this one that's right here. Okay, that's our sample. So our class data is 5.29. Okay, there it is. Use your calculator to find that standard deviation. Don't, don't do it by hand, because sometimes that's just crazy. It's a lot of work, and there's a lot that you got to keep track of. So as we said right here, our standard deviation was 5.29. Sorry, 9, not 5 again. Silly me. And there we go. Just to show you that what I did by hand was also correct, I can come back in here in stat, go into my list, scroll up to the top and clear and enter. And I can put in my values again, 23, 24, 25, 26. I need to scroll back up, fix the 25, 25, and 27. Hit stat, go to calculate. There is that standard deviation I found, 1.58. 1.58. See, let the calculator do the hard work for you. Don't do this stuff by hand. That's just silliness. And that is 12.3. That's all you have to do.